So welcome to Workshop 2. We're basically going to go over the entire workshop, and I'll explain how to visualize data. And I have no idea why this is named incorrectly. Must have been an error. Okay, I'll fix it with a git push later on. But basically, this week we'll visualize our data. So the reason why we visualize data is because when we're looking at numbers, or when we're looking at data through a data frame, I don't know if you guys have had enough experience yet, or if you guys have finished finding all your data sets and everything. But when you look at data in a data frame, it may not be the most descriptive. You see numbers and everything, but ultimately, a picture's worth 1,000 words, right? So the reason why we visualize the data is to basically show ourselves what patterns or what things are we missing that we can't see with normal data. And so yeah, that's why we're going to visualize our data. It's also really important for your presentations or for your abstracts, because you're going to need to, I don't know, data or graphs and charts would be a nice way to display your findings. Anyway, let's just get started here. So the main, okay, I'm just gonna, yeah, so if you guys are familiar with Geoplot which is R's version of, which is R's way of visualizing data, there's actually a really nice R implementation of ggplot and in Python, and so you can run ggplot functions in Python, and it's actually really good. I'm envious of our programmers, but anyway, let's get started. We're going to be importing some pretty standard libraries requests. I'm not pretty sure I don't even use this. I don't know, I'll probably remove it with a git push. Regex, pandas, we've gone through this last week. Okay, 2 new libraries this week. In Python, there's one dominant graphing library. It's called matplotlib. It basically is a quick and dirty way to show data from a data frame and to plot stuff. I'll show you guys later. Seaborn's a nicer library, but they have different strengths, and I'm going to be using Seaborn in this example specifically for showing a covariance matrix. And yeah, so just the 2 libraries. There are more. I know earlier in our chat we've talked about Plotly. Plotly is actually a great way. It's a great visualizer for graphs, but the reason why we're not going to be using Plotly this time is because you have to sign in, and then you have to do some authentication, and it's just going to take a long time, and it looks really nice. I highly suggest you guys check it out later on, but it's probably, yeah, it's not worth our time right now. We just want to get the basics done. So yeah, we've imported our data. Okay, so last week we made a data frame called the Workshop Rainfall data frame. I'm actually going to open up my BDC workshops right here. So Workshop 2. Oh wait, no, sorry. You guys can see how we have, I'm bad. Save data frame. Okay, Workshop 1 data frame. I shouldn't have opened it, but it's basically, oh no, my computer's going to crash now because it's really long. Sorry. Yes, that's not good. But yeah, this data frame is not included in the GitHub repo because it's a bit too large. So if you guys want to get started with Workshop 2 and skip Workshop 1, you're probably going to have to run every single cell in Workshop 1. Just run through the answers. There's a Workshop 1 answers, and that'll get you your data frame. But yeah, remember, the entire workshop is going to basically follow the rain data from the Toronto rain gauge meters. That data set's on the Toronto data website. But yeah, so it's in save data frame. Notice how we're to basically read the save data frame. Oh, wait, I'm bad. We have to specify the file path of where the data frame is, and you can see the pickle function. So yeah, I'm reading data frame, I'm displaying it with the head. I hope you guys remember this function. But yeah, here's our data. It's pretty interesting. Not really. But it's not going to be interesting until we start graphing, right? So on Matplotlib, let's jump into this. Useful to graph your stuff. So let's start by plotting the amount of rain by the time of day. Let's run a cell. Basically, we're going to store all the unique time values. So if you can see here, we have like different hours, right? We're just trying to get the unique hours, and we're also going to try to get all the rainfall values. So every single row will be turned into an index of an array using the .values command, and we're going to store that array into y. Yeah, let's print out x and y. Okay. So the first one is x. You can see that those are all the times, the unique times, and y is a very long array. So Python actually shortens it. There's a ... and so yeah, it can't really display that many indexes. So yeah. Okay, so Matplotlib has this really picky thing where when we're trying to display stuff as graphs, the x values should not be strings. I tried to work around it, but the most simplest method to work around this is to basically just to have some sort of continuous index and print it. Yeah, it doesn't really like to use non-primitive types as graph axes. So yeah, because it's an axis, and this is for like a continuous line graph, I believe. So yeah, that's why it didn't really like it that much. I'm pretty sure if you're doing like a bar graph, it'll definitely be easier. But yeah. Oh wait, no, it's a scatter graph. Yeah, I think you're gonna use. I'll just go through the tutorial. Anyway, so basically, let's try to get the list, get the unique times into the right class, because right now our x values, because they came directly from the data frame, they're actually of a type of they're actually a NumPy array, and that's the original type. And so we actually want to convert that into a Python list, because it's a bit nicer to work with. I don't know, I ran into some error when I first did this, and it didn't really like NumPy arrays. But before I move on, you guys have any questions? You could use data frame class to convert them to times. That's very true. Yeah, I can. Anyway, but yeah, let's just go through the tutorial then, if there are no questions. So we're looping through each unique time and using its index as a unique continuous variable. This is the index of the time. So like 12 o'clock a.m. will be index 0. 12:05 a.m. will be index 1. And so we're just using this index to serve as the continuous primitive type variable. It's gonna take a while because we have like a lot of rows. But anyway, we're gonna show that as a head really quickly. That's values typing. Okay. So now that this is running, we actually don't really need this x variable. So I'm just going to run command. Still waiting. Thoughts? No. Yeah. Okay. Give it a moment. Yeah, so our goal is to basically get two arrays right now, one for the x-axis and one for the y-axis. So the index of each, so the index is index 0 from the x array corresponds to the y index, or the index corresponds to index 0 of the y array, and so these two indexes will describe a point on the graph, and so using these two arrays we'll be able to plot them onto a graph, right? Right, so head. Yeah, so we have a new time index. This is double. It's of type double, I believe, but whatever. It's a primitive type. Python likes it, so we can use it. We've overwritten our x variable because we really don't need the x. We don't need this variable. X is simpler. Now let's construct our graph. Plot x and y must be the same. Shoot, I probably messed up somewhere. Okay, let's watch me debug code live. That's really weird because they are of the same size. Shoot, Mark, help me out. This is bad. I actually have no idea what's going on. Okay. Well. Oh, I'm dumb. Right. X is not the X values, it's the actual data frame. So, wait, so yeah, Y is the actual array. Okay, so here's what we have to do. I sort of, damn, I might have to fix things up a bit, but, okay, so, X is equals to, oh, right, I messed, with the values of time index, oh, right, I didn't follow my own tutorial correctly, but, yeah, time index. So, you see what I'm doing here, right? We're basically trying to grab the values of the time index and save it into an array. And so now, if we print x right now, yeah, it's actually an array of the time index values. I mistaken it for the data frame before. Anyway, let's plot this, and it should plot. Yeah, it's just rendering. I actually have a lot of things open in my computer right now, so it might be a bit slow. Okay, this is really interesting. So notice how like different times of day have like different like precipitation values. So like apparently like I don't know, like midday, like this is probably around 2 o'clock or something. There's a lot of rain, or like all the rain gauges have like detected a lot of precipitation. But like you can see there are these I don't know valleys. I don't know, it might be like some sort of sensor error, but it also could relate to how the actual weather in those areas are. So, like, okay, here's a great example of why we should plot things, right? Because if we looked at these numbers, like, oh, there's like 0 precipitation for this time, whatever, right? So, okay, that tells us like literally nothing. But once we plotted the data, we could actually see patterns in when rain fell. And so this is really interesting. This is why graphics is important. Whether you're working with text data, if you're working with categorization, always plot your values. If you don't know what you're doing, or if you just like plot values every once in a while, because they'll tell you a lot more about your data that you never knew about. Okay, so the plot right here is a bit small. Let's just fit this. So I'm just showing basic matplotlib functions to basically tweak your plot around. Changing your font size. You can like I don't know, change the color of your dots and everything, but yeah, it's a bit larger now. We are missing some things though, because like notice how there's like no values or titles. We want to basically include these titles and labels, because if you're gonna be putting this in your abstract, you would want these titles and labels. Let me just admit people. Yeah. No, X wasn't that. Amount. Time. Okay. Now if we go print this, you can actually see that. Oh yeah, all the labels are here. So, one thing to note, if you guys ever generate a graph and you think it would look amazing on your abstract, right click, you can just save image as, and it'll save, or you can open image in a new tab and, you know, do the same thing, right? Just save as. And so yeah, that's how you basically save images. It's really easy. Spice is clear, graphing, okay, yeah. I was just exclaiming at the distribution right here. But, oh, yeah, okay. Okay, yeah, I like to plot two variables against each other and look at the correlation. Oh, okay, so, when you're looking at a data set, right, you don't, you first want to get some more information or context about what you're looking at. So, one thing that most people do is they want to see which data are similar to each other, which data correlate to another, right? So, if we're looking at rain data, we'll probably see that if the temperature is really high, we're not going to see that much rain. So that's a correlation that we can see. But for more obscure attributes in your data set, remember attributes from last week's workshop, which is the columns or useful features. Yeah, it may not be so distinct. We may not see these. We may not know what correlations there are, and knowing about correlations is really important because sometimes when you go on to data modeling, when you look at two correlated variables, if two variables are highly correlated with each other, they may actually induce a false sense of a correlation or a false predictor variable for your machine learning models, and that'll basically mess up your models because now your model thinks that if these two values are both really high, but they're both really correlated to each other, they may not tell or give different information. The information from the features will skew your model because the information they tell are too similar and it's not distinct enough for a machine to basically realize that, hey, we probably shouldn't be basing our predictions off these two variables. So it's up to your duty to prune these highly correlated variables. Let's actually start doing this. This is just a basic function I found online. It basically plot correlation map. Yeah, okay. It basically takes a data frame. What am I doing? Wait, timer. Oh, I'm bad. I didn't copy. Yeah, it takes a data frame. It looks at every single variable, and then sees its correlation between each other, right? And so, yeah, you can obviously see the IDs are attributes of the same name are highly correlated with each other. Like time index and time index, because they're the same value, right? So it's a correlation matrix. I know Nahal actually had a nice example with vehicle emissions and vehicle speed and how they correlate with each other. And so right now in this scenario, rainfall and time may not correlate with each other, or ID will definitely never correlate with any of these other variables. But so this is probably not the best of examples. But you can see, and so the correlation graphs will show, hey, these things aren't correlated, and so I don't know, it's just a useful tidbit to know. Before I move on, do you guys have any questions? Okay, I'm just gonna move on. Yeah, feel free to unmute your mic if you wanna speak to me. Anyway, yeah, as expected, the variables don't really correlate with one another, but yeah, c'est la vie, right? Okay. Now that we have correct. Okay, so I actually want us to plot the downpours of rain on top of a map of Toronto because visualizing, I don't know. You guys have learned how to visualize values onto a scatter plot. Line plot's not too far away. You can Google that. It's just the syntax in the library I want to introduce you guys to. The idea of correlation is also pretty important. I use that a lot. Yeah, I use the scatter plot and correlation sometimes when sorry, not a lot, but yeah, sometimes when I first look at a data set. But for you guys, something that might actually pertain to your analysis is plotting stuff geographically. So I'm actually going to read our data files. So right now, if we look at our data, these are all the 2017 February, January to April, August data sets. Oh no, I'm gonna crash my computer. Basically, yeah, we're gonna load up all these files and we're gonna put it into one giant data frame. So thing how I'm doing it is there's an array, and every index of an array is the one data frame. And so yeah, this turns into a data frame, right? Turns a CSV file into a Python data frame. So let's run .head on this. Oh wait, what am I doing? On the zeroth index. Yeah, I'm pretty sure you can't run .head on a Python list because it's not of the Python list class. That's for data frames. But yeah, so I'm looking into the data frame of the zeroth index. And so basically these first 6 data sets, they're basically describing the name of the station, the weather station, or the rain gauge meter, when they took the reading and the amount of rainfall. Yeah, it's just here to show you that the 0 and the 5th, the first 6 are the same type, and then the ones afterwards are of a different type of data set. Basically, it displays the latitude and longitude of these rain gauges and the name of the station. So, right now we want to basically merge these two data sets, so we have one data frame to work with, and so we're gonna match how much rainfall had fell on a latitude and longitude, right? So here's what we're gonna do. We're just basically going to append data frame after data frame after data frame onto a data frame, and this is how you would basically just like plop a data frame underneath a data frame. I want to say join, but I think, or concat or merge, but they have different meanings, and I'm not too sure about them. But I'm pretty, yeah, I think it's join. You would just join one data frame underneath another one. Mark, correct me if I'm wrong, please, because I know you're watching this. But yeah, okay, basically, so here's an issue. We noticed that in our rainfall data frame, the data frame that contains all the values, all the precipitation values, there's 1,800,000 rows. However, the data frame that actually contains like where the locations of the stations are, there's 276 rows. So we basically want to say if this rain reading has this station name, we're gonna find this station name and plop its launch and like merge it onto the side. And so we'll do that every time we'll see an RG_001, we'll merge it here. So like these first 5 indexes will definitely have the value, long value of this first data, of this first station, lat longs, whatever. But the reason why people do this instead of just having one giant data frame is because there's, oh no, yeah, it's because the sites or the locations of these data sets, oh no, actually, that's actually probably going to crash as well. But yeah, the sites may change. These stations may move. They may move the rain gauge, or they may move places. And so instead of like changing the lat long values of where the rainfall data was taken on all the rows, which is like 1,800,000, they can just literally change like one value in a file, and then later we can match them up again and it'll be correct, right? Or something like that. But you'll see a lot of data sets split part of the data because of reasons like I've mentioned. Anyway, there's a README for it. You can look at it here, and it'll basically show you, yeah, which type of data set says which. Okay, so here's another issue. We can't just simply match the two data frames together because, actually no, we can't. But I'm going to explain something I found. The unique station names in rainfall data frame, there's only 45, but there's 46 in the data frame. This probably means that there's 45 different stations, but there's probably one extra station location that was either built but its recordings haven't been stored in this data frame yet, or it used to, but then this version of the data frame didn't have any values of it. Anyway, either way, we have more than enough geodata locations for the amount of required station names, so we can basically just merge them together. There's a merge function, merges on the rows, because we realized that the name column describes the name of the stations, and so we can just like concatenate or merge these two tables on this name column. We're doing an inner join or an outer join. There's a different when you're merging data frames, there are different ways or different methods to join. There's actually a really great image of it online on the Pandas website, but for the most part, you'll probably be using outer. If you have like some weird specification, or if you need to do some more complex in name, you should probably Google how to do it, and it might not be an outer join. But yeah, so either way, the left data frame on named, right on named, pretty standard. You can see now we've merged the two. Okay, and so we run it. I'm basically going to drop the ID underscore x because we really don't need that, and ID because they're basically the same ID. They got copied during the process. I think yeah, there's probably some command in here to prevent that from happening, like duplicate column names. But yeah, you'll have to research that. I don't know. It's just simpler to drop it. Oh, okay, yeah. So notice how these names are a bit weird. I'm just renaming the names, so I'm just showing you more methods how to rename it. Basically copying the data frame, and I'm reordering the IDs of the column just because I want the IDs to be on the left side. Because it makes your code cleaner, and well, further down the line, you're gonna appreciate it. So yeah, let's save it to a pickle file, and so next time we bring it up, we'll actually have a nice and ordered index or title for our data frame. My computer's doing a lot of things at once right now, so it's pretty slow. But before I move on, do you guys have any questions? Alright. Okay, I'll just continue. So now that we've saved our data frame, we have our latitude and longitude, and we have the amount of precipitation for every single point. So we're gonna go into mapping. So the Python geomapping library is not the greatest. It's actually pretty poor. There's actually something called basemap. I've actually made a completely separate notebook just to explain basemap. But basically, like, you're gonna get like stuff that looks like this on a Geoplot, which is fine, but it's not the prettiest. And honestly, it looks really ugly, and I don't know, lines are really sharp. So yeah, Python really lacks behind R in terms of visualization, and like even ggplot's a lot better than matplotlib, I'm gonna be honest. But Python's catching up. Like, just check this out. If we're gonna, I'm gonna come back to this when it's done processing, but we want something nicer. There is something called Folium. So this is what we're gonna be using. So Folium is basically built on top of a fantastic mapping library called Leaflet. Have you guys heard of Google Maps? Yeah, Google Maps is a nice mapping library, right? But Leaflet's a better mapping library. The graphs or the maps from Leaflet looks a lot better than Google Maps. Oh shoot, there should be a web page. Yeah, it's originally like a web port. Anyway, like, it's just a lot simpler, and and the Google Maps implementation was not that good. So someone made a really nice Leaflet implementation for Python. So it's called Folium, and you can plot stuff in Folium, and it looks really nice. So I'll basically just run these cells. basically, I'm pip installing the Folium. I already have the requirement installed on my computer. We're importing the library. Okay, and so here is a Folium map. It's interactive. I've tried like my best trying to like store it or save it. I'll go into that a bit later. But because it's interactive, it's a bit harder to save than an image, right? So to make a map, we basically do m is equals to folium.map. Latlong, this is where you want the map to start, and the zoom level. It's pretty simple. Oh yeah, those are the coordinates of Toronto. Okay, so let's try to do something fancier. We can place points on Folium. You can see I'm the M object we created earlier. M is the map, right? I'm adding pop-ups to the map. So these are the different latlongs, and you can see if I click on these values, you can actually like store data into there. So this is actually pretty interesting because if you have like higher dimensional data, let's say you want to display more than lat, long, and amount precipitation, you can actually have like more data or like higher dimensional data described into these points. So you can say, I don't know, the color of this rain gauge is blue or something. You can describe that in these like pins or pop-ups. It has its uses somewhere else, particularly in text data. Text data is really important. But anyway, let's just continue. So we're running into an issue right now. Okay, how many digits is this number? There are like 8 digits. That's 10.8 million rows. My computer cannot handle 10.8 million rows on Leaflet. It's gonna crash. So let's just do something simpler. Let's just sample a subset of our data frame, and we're gonna save it into a small data frame because you really don't need to show all 10 million rows to have an impact, you know. That's why people sample a size of a population, not like the entire population. Okay, so instead of displaying pins all over the map, we're going to display a heat map because I don't want to see a bunch of pins everywhere, and I'm pretty sure heat map is a lot more descriptive than pins. So this is the Folium heat map. This is one of the main reasons why I chose this library, because it has a decent heat map. You can see like which areas of Toronto suck. So yeah, there's a lot of rain here, not too much rain here. If you go in deeper, these are all blue, right? But so the way most heat maps work, most heat map libraries work, is they'll basically take a look at all the values on the map and say, hey, this map has like 90% of all the precipitation, so let's make it redder. And so it takes into account how red a dot is depends on how red everything else. If you only have one value on the map, it's going to be 100% red, right? If you have more, then the percentages will spread out more. And we can see this here, right? If we zoom in on just one dot, it's 100% red. But if we zoom out, like it's actually a green dot because it doesn't have that much precipitation. And so you can see here, there's a lot of precipitation here, hence why this area is a bit more red when we zoom out furthermore, right? Further out. And so yeah, Folium is a nice heat map library. So these are only 1,000 precipitation values from the actual data frame, and so yeah, subset will work. It's fine. A million is probably not going to change. Like a million rows may not change your accuracy by too much, but yeah. One more thing to note: this sample command is useful in not only displaying like data, but it's also useful in machine learning algorithms. So because when you're running a machine learning models can take like hours for them to run. And if you're gonna run like if you're gonna run your model on 10 million rows at a time, it's gonna take like a really, really long time for your model to predict or to train. So most computer scientists will basically sample their data set and feed the sample into the machine learning model. And so this way you can like adjust your hyperparameters and get into the ballpark of where you want your machine learning model to be. And once you're in the ballpark, you can perhaps add more data into the training test size, the sample, and then that's going to basically help improve your accuracy even more, right? And because machine learning models suffer from a lot of diminishing returns, putting in 1,000,000 rows may not necessarily be that much of an improvement over 1,000 rows, right? But actually, no. When you're working, yeah, that's important. I'm going to say that. But the point here I'm going to make now is, you do want a lot of data, but 1,000 rows is not going to be enough. So maybe like 10,000 rows. But like over like 10,000,000 rows is probably going to be a bit too much. But and it's going to be too slow, right? So you have to take into account time and results, or the kind of results you want when you're working with machine learning models. So there's my spiel about machine learning models. Okay, so yeah, we have our heat map. So okay, we're going to try to put into location stations. Notice how we don't know where stations are? Well, we can guess that they're in the middle of the heat map, but I also want to show in there a feature of leaflet, folio. So here's what I'm going to do. I'm basically going to plot the location latlongs of the stations onto the heat map so we can see it. Basically, I've read the location of all the sites. Here is the data frame. I've ran a map. Let's just run the code and see how it looks like. So yeah, you can see now there are red dots all over the map, and those are the locations of the stations. Yeah, basically it's pretty simple. I'm making a new map, and every single row in the station, I'm gonna add a circle marker to the map object and make it red, fill it, lat long, radius 1, you can change radius. A larger radius means a larger dot. And yeah, you can also have it like, you can have your variables displayed like this. It's also acceptable. But anyway, so here we have our rainfall station data. And let's actually add the lat longs, the heat map, on top of this M3 map object. And now you can see we have our stations. They're in the middle of every single heat map location, and it looks pretty nice. Yeah, pretty cool. Anyway, we can't. Now, how do we save this map, right? Because we want to basically put it on our abstracts or showcase it on Big Data Day. We want to have like a static map to show. We can't save as an image. No, it doesn't work that way. It's an interactive map. So there's this really awesome function called save. And so we can actually do save as, I don't know, let's call it heat map for Toronto. Precipitation heat map. Precipitation heat map. Okay. Okay. And now, if we look into our answers, there's an HTML page. I open it, and then I have no idea where it went. Okay. It's probably open in one of my Chrome windows. Open with Firefox. Sure. But anyway, yeah. You can save your files and open it up. I've tested it before it works, in case this thing doesn't load in time. But that's basically how you display simple things in Matplotlib. Oh yeah, so here's your map. Unfortunately, yeah, it saves as an interactive map, but if you do want to take like photos of it, you can't like save it as a photo. You have to like screenshot your screen, and that's the best way to take a photo of it. But yeah, so this is leaflets. Pretty interesting. Okay, that's basically the end of workshop 2. Do you guys have any questions? Yeah? No? Alright, I'm gonna guess no one has any questions. So, yeah. Basically, yeah, okay, so if you want to use the native Python, oh, what I didn't show you guys basemap, right? Conda install basemap, whatever. Here's basemap. This is Toronto, guys. I told basemap to basically to show me Toronto, and this is Toronto. This is really bad because like you can't see any details, like not descriptive. So yeah, basemap's bad. I try not to use it. I used it for my analysis last year, and this is what I got. It was okay because I was like graphing Canada, right? But like, yeah, it's not the most high definition map. So yeah, that's basically about it. It'd be nice if you guys could work on. You can change the resolution of basemap. Oh, I'm pretty sure I tried that. I don't know. Resolution. Yeah, there are different types of resolutions if I remember. I don't know. I just copied and pasted from my thing last year, but either way, you're not gonna get like the richness, or you're not gonna get the rich colors that like our mapping libraries provide, right? And I don't know, streets may not be implemented that well in basemap as well. So yeah, I highly suggest using other libraries. Plotly is a great alternative as well, like I mentioned earlier. But yeah, so I think everyone should. That's basically it. Workshop 3 is going to be out soon. Actually, Workshop 3 is in 2 parts. One of them is in linear regression, the other is in k-means. And so, yeah, we're gonna push up the linear regression one first. It's basically the same size as, or same length as Workshop 2. But those are basically the 2 machine learning models or algorithms we're going to be focusing on. Right now, please tell me you guys have actually looked at datasets and have like maybe perhaps done sort of the cleaning or I don't know, a categorizing or feature selection of your datasets. Because if you are like going to leave this for like the last week, your computer may not handle it, and if you're working with millions of rows, it's probably gonna be too slow. I remember, yeah, I had spent like nights doing this, and it really wasn't good because I can process the things in time. But so yeah, work early, start early. If you have any problems, please ask our mentors because they're a great help. I will be posting the answer to this workshop online. Resolution can be C, of course. Yeah, the resolution parameter is C in my basemap example. C, of course. But, or crude. Oh, low, intermediate, crude. Oh, wait, let me just change to intermediate really quickly. But yeah, start early in your projects, get the help you need, and really, we've tried to simplify everything this year. We've found datasets for you guys, and we have we brought a lot of mentors, and we actually have these workshops in. This wasn't here last year, so yeah, I really hope you guys are doing well. I guess that's basically it. Yeah, you guys can leave now, but I'm gonna be posting this and the stream online in a bit. I'll probably cut this section out. But oh wait, that was color. Yeah. Oh, one more thing I want to note. When you guys are like analyzing things, right? You guys may want to use the fanciest libraries, but keep in mind you may not find that much support when doing so. So like that was the only reason why I include the basemap tutorial here, is because like basemap's been around forever, and there's a lot of like support and help online or Stack Overflow forums on the basemap library, but not so much so for Folium or Leaflet, right? Or well, Leaflet probably, but not for the Python implementation Folium. And so just like keep in mind that if you want to use this fancy library, make sure it's relatively bug-free, hopefully, and make sure if you're not that strong in programming, I would definitely suggest going with the more popular libraries, because if you run into any issues or errors, more people will basically be able to help you, and more of us can help you in response as well. So yeah, basically it. Oh shoot, I'm actually a bit late to my team's meeting, so I'm gonna call it. And yeah, so have a great one, guys. Work on Workshop 3. We're gonna send out the stuff, and yeah, goodbye.